Alrighty, this is homework 2. We don't have a worksheet for this, so I just went ahead and put the problem on here. A driver is to test the braking of a car equipped with anti-lock brakes, which can decelerate the car at the maximum possible rate without the tires skidding. The test is made on a dry, straight section of a test track. In response to a visual signal, the driver stops the car in the shortest possible distance. The stopping distances for 6 initial speeds are given in the following table. A. Find an expression for the stopping distance d in terms of the initial speed v, the response time tr of the driver to the visual signal, and the magnitude a, which is assumed to be a constant. Okay, so here, as you can see, I have created the general equation, which is truly just equation 2, which is the integral of our velocity with respect to time equation. So it's displacement equals initial velocity times time plus 1/2 acceleration times time squared. And then from there, so obviously at the moment we don't have, going back here, we only have meters per second and distance. So we only have that displacement and initial velocity. So in order to get acceleration, we want to look at equation 4. And what equation 4 allows us to do is this right here. This is obviously the most simplified version of it, but it allows us to take final velocity squared minus initial velocity squared, all divided by 2 times delta x. And once we have acceleration, we're able to find time. And that's with equation 1, or just our velocity v of t equation. And that is just final velocity minus initial velocity divided by t. That gives us time in seconds. And on this final page, these are the actual measurements I took. I went ahead and put this together in Excel as you had recommended. It worked out great. So as you can see here, we've got meters per second of all our tests in meters. And then these are the equations I've used. So I'm given the magnitude of acceleration and the amount of time that's elapsed. So here we've got acceleration in the form of velocity squared divided by 2 times meters. And here's your readout as follows. And then seconds, as we went over earlier, which is initial velocity divided by acceleration. And as you can see, these are the answers. Pretty straightforward assignment, I should say, but pretty cool using Excel to mess around with the numbers. Alrighty. Hope you enjoyed.